All right, you guys, up to this point, we have talked about ways to show that triangles are congruent, which in order to do that, we have to show that all three sides and all three angles are congruent. But what if I told you you did not have to show that all three sides and all three angles in a triangle are congruent for two separate triangles to be congruent? Whoa, Miss Long, you're talking like cray-cray right now. Like, what are you talking about? You're talking crazy stuff. I am not, you guys. There's a way that you can only show three parts of a triangle are congruent to show that both of the triangles are congruent. So this could be a combination of sides and angles that would make your triangles congruent. But there are certain shortcuts that work and certain shortcuts that don't work. So we need to go over those real quickly. Okay, so you can see that two triangles are congruent without showing that all three angles and all three sides are congruent. So let's talk about these shortcuts. There's a total of 4. I'm going to go over 2 with you right now, and I'm also going to go over with one of the combinations of sides and angles that does not work to make sure the demon cats don't get us. Okay, so the first shortcut we're going to talk about is the side-side-side postulate, which the side-side-side postulate tells us if I can show that 3 sides of one triangle are congruent to 3 corresponding sides of another triangle, guess what, you guys? That is enough information to show that your 2 triangles are congruent. Holy hot dog, right? So if you just show that all 3 sides are congruent, your triangles are congruent. Sounds great, right? I also have another shortcut for you called the side-angle-side postulate, or the SAS postulate, the SAS. It's got some sass, the sassy postulate. So, now this one you gotta be careful, you guys. The order in which you see the items in the triangle is very important. Okay, the side-angle-side postulate is where you have 2 congruent sides in a triangle with 1 congruent angle that is located directly in between the 2 congruent sides. So we have a side, then the next thing you see, usually what I do, I kind of trace around my triangle, and I see what is marked congruent as I go. Now, how you know where to start at, you usually start with the outermost congruent parts that are marked, and you don't want to skip more than one part not being congruent. Like if I start at this tick mark and I trace around, I don't have a congruent angle, I don't have a congruent side, and then I don't have a congruent angle. That is a problem. Okay, when you trace around your triangle, you cannot have more than one missing congruent side or angle. So you start from the outermost objects, and then you kind of go around your circle, and go around the triangle, and you see what is marked in as congruent. So like if I start here, I start with a congruent side, then I shift over and I spot a congruent angle, then I shift over and I spot a congruent side. So SAS must have a side, then directly after it an angle, and then directly after it a side marked congruent. Okay, or the other way you can think about it, you have 2 congruent sides with an angle that is congruent right in between the 2 congruent sides. So that is the SAS postulate, or the SAS postulate, the side angle side. Now, there is one postulate we need to talk about that is not allowed in proving triangles that are congruent. So, let's see here. I'm going to scroll down. Okay, so this postulate right here. We talked about the SAS postulate that has 2 sides and an angle that are congruent. Well, if I rearrange those letters, I can call it the side-side angle postulate, which is actually not a postulate. But anyways, side-side angle, or the SSA postulate, which is not a postulate. Okay, this is not enough information to show that your triangles are congruent. And again, it's all about how these things are lined up on your triangle. Okay, if you notice here, this is a triangle that is congruent by SSA. Okay, I have a side that's congruent. Then I go to my next thing. I have another side that's congruent. And then I have an angle. So if you guys see here, the angle is not in between the 2 congruent sides. In SAS, or side angle side, the angle is in between the 2 sides. This one, the angle is not in between the 2 sides, so watch yourself. Okay? Which, first of all, you guys, if you look real closely at SSA, it kind of spells a bad word if you look at it the other way. Okay, I'm not going to say that word because it's highly inappropriate. Okay, but in math, we don't say bad words. So obviously, if we have a postulate that spells a bad word, then it can't work out, which this one does not work out anyways. And down here explains why it does not work out. Okay, so if I have a triangle with two sides and an angle that are congruent, okay, if I have another triangle that has the same two congruent sides and same angle, you can create a triangle that is not congruent to this one. So this is not enough information to show that your two triangles are congruent. And the way this works, okay, so if you kind of imagine taking the side right here, same as this, and you swing out that side. So if I swing this side out and I change angle B, which if you see, angle B is not one of the congruent angles, so I can change angle B. If I swing out angle C, I can change the measure of angle B, and then I create a different triangle. So these two triangles are definitely not congruent. Okay, I can create more than one triangle if I arrange two sides and an angle congruent that are not right near each other. The angle is not in between the two sides. If you arrange the congruent sides and angles in that way, you can create a completely different triangle, which is not what we're going for. We're trying to show that two triangles are congruent with the fewest amount of parts possible. Okay, so the SSA postulate, the angle that is not in between the two congruent sides, this does not work. It's not a postulate. I shouldn't keep calling it a postulate. Okay, so you cannot use SSA. If your triangle is showing SSA markings, first of all, the demon cats will get it. But secondly, it is not enough information, and you will not know if your triangles are congruent. So just keep that in mind. Okay, so now going back to where we were, in examples 1 and 4, I have given you 4 different pictures that contain two triangles. Like this one has these two triangles right here. Example 2 has these two triangles right here. Example 3 has two completely separated triangles, and example 4 has these two triangles that are right next to each other. So it says, which postulate, if any, could you use to prove that the two triangles are congruent? Okay, so we're trying to decide if I can show that the two triangles are congruent currently with the SSS postulate. So if I can show that all 3 angles are congruent, or if I can show they're congruent with the side, angle, side, or SAS, the sassy postulate. And again, if we spot any triangle that has SSA, the demon cats are lurking, and it will not work to prove triangles are congruent. You better watch out, the demon cats are vicious. Okay, well, let's get started on example 1, right? I mean, I know you've been dying to solve example 1 this whole time, so let's get going on example 1. And I don't know, there, okay. All right. So I have example 1. These are the two postulates we're trying to use to show that these two triangles are congruent. Okay, so these two are the happy cat. They're the ones that work to show that triangles are congruent. SSA, though, does not have enough information to show your triangles are congruent. So watch yourself. The demon cats that breathe fire are always lurking. You better watch out. But anyways, let's get going. Okay, so like before, I'm going to go ahead and list everything given to me in my picture. Okay, because that's going to help me to work my way toward either SSS or SAS. So let's see what happens, you guys. All right, so currently, do you guys spot any congruent sides in the picture? Holy hot dog, I see it too, you guys. I see that AC and CE, these two segments, both have one tick mark, which means they're congruent. So I can say segment A to C is congruent to segment CE. And the reason why is because it was given to me. It was in the picture. They gave it to me in a nice golden platter. It was lovely. Okay, so these two are congruent because it was given to me. Okay, so I got a side marked in. Okay, so now, do you guys spot anything else in your picture that is already marked congruent? Holy hot dog, I see it too, you guys. Do you see that DC and CB both have these two tick marks? That means they're congruent. So I know DC is congruent to CB. And again, this is because it was given to me. So my reason is the given. All right, you guys, so currently, I've used everything possible in my picture to show that two sides are congruent. Okay, so nothing else in my picture is congruent. And I definitely don't have 3 sides right now or 2 sides and an angle. All I got is 2 sides. Okay, so this is not enough information yet to show that these 2 triangles are congruent. Okay, so I've got to try to use one of those tricks up my sleeve to help me show something else in my picture is congruent that maybe would lead me to show that they're congruent by SSS or SAS. So let's see here. Our tricks up our sleeve. We can either use a reflexive side or angle, which is a shared angle and side. Well, my picture is not, these triangles do not share any of the same sides or angles. They are not overlapping at all. They're kind of like resting on top of each other. So the reflexive property is out. Also, the other property we talked about was the third angle theorem. Okay, and in order to use the third angle theorem, I have to have 2 angles that are already congruent in my picture, which I definitely don't. Like, I don't have any angles congruent, so that's not helpful. Now, the third trick up my sleeve is to use vertical angles. So you guys spot any verticals. Do you see the X? Whoa, do you guys see the X right there? I totally see the X. Do you see the X? Whoa, look at this X. Insane, right? Okay, so I found 2 vertical angles. And how do vertical angles relate to each other? Holy hot dog, they are congruent. So I now know that my 2 angles are congruent. Now, be careful. I cannot call this angle C. There's more than one angle at angle C. So I have to name the angle 3 letters. So this would be angle ACB. Angle A to the C to the B is congruent to angle D to the C to the E. And the reason how I know this is because they're vertical angles, and vertical angles are congruent. So this is the vertical angle theorem. Vertical angle theorem. Okay, so I have 2 sides and an angle given to me. So these 2 triangles are not congruent by SSS because I need 3 sides, but both of these types of, one of them's a real postulate, one of them is a fake postulate, so be careful. Okay, these 2 contain 2 sides and 1 angle. So I need to figure out, are these 2 triangles congruent by SAS, which is acceptable, or SSA, which is not acceptable, which means they're not congruent. So let's see, it's all about where things line up. Okay, which SAS has 2 congruent sides. Technically, this should have another tick mark, technically. I should have 2 sides that are congruent with an angle marked congruent in between them. If it's SSA, I have 2 sides that are marked in as congruent, and then the angle is not in between the sides. Or if you go around your triangle, you see a side, then an angle, then a side. In this one, you see a side, then a side, then an angle. So be careful. Okay, so I'm going to start from the outermost markings in my picture. So I could start here or here. It doesn't matter. And I need to trace around my triangle in a way where I don't go with more than 1 angle or side not marked congruent. Like if I go this way, this angle is not marked congruent, this side is not congruent, and this angle is definitely not congruent to anything. Okay, so I can't go this way. I have to go away where I don't skip more than 1 item that is not marked congruent. Okay, so just be careful. So first, I see a side right here. I see a side. Then if I keep tracing, I see an angle marked congruent. And then if I keep going, I see a side. So what do you guys think? It is by the SAS postulate. Whoa! Cool beans, right? So this triangle is showing the SAS markings, but I gotta be careful, you guys, okay? Because if this one has SAS, this triangle needs to be marked in the same way. If it is not marked in the same way, then the 2 triangles are not congruent to each other. So I need another SAS. If it's not SAS, then these 2 are not congruent. So I really hope it's SAS, because if it's not, it's going to be really sad. But anyway, so let's see here. I'm going to start from my outermost markings. I'm going to trace in a way where I don't skip more than 1 part marked congruent. So like this way or this way. So I see a side marked incongruent. Then the next thing I see is an angle. And then the next thing I see is a side. So guess what, you guys? This triangle is also marked as the SAS postulate. So since both of my triangles have SAS as their congruency markings, the two triangles are congruent by SAS. So now that they're congruent, I can write my congruency statement. Holy hot dog, right? Yes. Okay, so I'm going to say triangle, which it doesn't matter how I name this top angle. I'm just going to call it ABC to make my life easier. So triangle A to the B to the C is congruent to, now, remember the order that we go in is very important. If I trace my triangle from A to B to C, like this, I go from 0 tick marks on my side to 2 tick marks on my side to 1 tick mark. So I go from 0 tick marks, to 2 tick marks, to 1. So my next triangle, when I trace it, I need to go in the order that has 0 tick marks to 2 tick marks to 1. So what do you guys think? How can I name this bottom triangle? All right, it'd be triangle. The side with 0 is this one. I just need to figure out which way to go. If I go from 0 to 2, here's my 2 tick marks. I kind of need to head this way. So I'm going to start at E, go to D, then go to C. And guess what? 0, 2, 1. 0 tick marks, 2 tick marks, and then 1 tick mark. Yay! So it'd be E to the D to the C. And they're congruent by SAS. And guess what, you guys? That's it for example 1. Pretty cool, right? We didn't have to show all 3 sides and all angles are congruent, which is pretty awesome. Well, nice job, you guys. That was great. Now we're ready to tackle example 2. Let's go.